The trick to understanding significant figures really is the zeros. Are they significant or not? So let's just look at this. In number 1, what we find is that we have 4 trailing zeros, but there's no decimal. Since there's no decimal, that tells us that these 4 zeros are placeholders, and therefore what we have here are just 2 significant figures, the 9 and the 8. Let's look at another one of these. Let's look at number 6. Here we have both leading zeros and 1 trailing zero. Now remember, leading zeros are never significant. That just leaves us with 2 possibilities, the 4 and the 0. Well, the 4 has to be significant. The question is this 0 here? The rule is a trailing 0 is significant if there's a decimal. So in this case, this is a significant 0, so my answer here should also be 2. Now let's look at number 7 then. Following the same logic, we find is with number 7, I have trailing zeros and a decimal, therefore those are significant zeros. I have 4 significant figures here, 1, 6, 0, and 0. Let's look at number 3. All I have here are a bunch of zeros that are leading. Leading zeros, never significant. Non-zero numbers, always significant. So that just leaves me with, once again, 2 significant figures. Let's look at, let's try number 4. Now number 4, I have trailing zeros, no decimal, therefore they are not significant, and I only have 1 significant figure. And if we look at, say, let's look at number 10, what we find is we have both leading zeros and trailing zeros. The leading ones are not significant. Since the decimal is present, the trailing zeros are significant, and that gives me 3 significant figures in this case. Okay, now let's look at what's more important, and that is how to round our answers for the correct number of significant figures. What we'll find is that if we type in a simple problem into our calculators, for instance, 1.93 divided by 3.4, we get this outlandishly long answer that comes out of our calculator. What I want you to do is break yourself of the habit of slavishly copying down all these numbers. The main reason, and 2 reasons. One is it's a waste of your youth, and the second one is most of these numbers are meaningless. They are not reproducible, they are therefore not significant, and we don't want to write them down. They would mislead our readers. If we wrote all this down, a scientifically minded reader would say, wow, you had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits of precision. That is just unprecedented. You must be working at Caltech or MIT or someplace like that to have that kind of data. The reality is we have very mediocre data at best. We have 1, 2, 3 digits here, and we have 2 significant figures here. The rule is a chain is only as strong as its weakest link. This number here must be rounded to the least number of significant figures that we were working with, which in this case is 2. I get to keep 2. I get to keep this one and this one. I get to keep the 2 and the 6, and then I look at the next one. The rule is if it's a 5 or greater, I round this one up. If it's 4 or less, I leave this one alone. Since this is a 5, I'm going to round it up, and what I will record is 2.7. That is how I would write the answer to this. I don't care if your calculator spits out all this mess. I want you to write 2.7 because this 7 is reproducible, the rest of this is not. Let's try another one. So on number 12, what we see I have is 1, 2, this 0 is a captive 0, so it is significant. 4, I have a total of 4 significant figures here. I have trailing zeros with a decimal that makes them significant, so therefore I have 1, 2, 3, 4, 5 significant figures. The weakest measurement is here, the one that has 4, so I'm going to round this answer to 4 significant figures. I start on this side over here and I say, okay, I'm going to keep the 8, that's 1, the 0, that's the second one, the 5, that's my third one. I get to keep one more, the 6. Now I look at the next one and it's a 3, so I'm going to leave the 6 alone. But watch what a common mistake is. A frequent thing I see students do is this. They'll say 8, 0, 5, 6. That is true. Those are my significant figures, but the problem is this number here is 8,056. This is 8,563. This number is not a rounded version. This one is different. And what I always say is if you owed me $80,560.80, I would not say, why don't you just pay me 8,056? The trick here is I have to add a placeholding 0 at the end here. If I put a 0 here, it keeps all these other numbers in the correct columns. It keeps this in the 10,000, the 1,000s, the hundreds, the tens, and the oneses. And so you find that sometimes, as counterintuitive as it is, you have to add this placeholding 0. Now notice there's no decimal. If there was a decimal, this would be significant. But as it is, this is 1, 2, 3, 4 significant figures, which is what I'm limited to here. Let's look at number 13. Number 13, I see I am limited to 2 significant figures here. So therefore I have to limit this answer to 2 significant figures. Now remember, leading zeros are not significant, so we're going to ignore this 0 here. So that means I'm going to start counting here. I'm going to keep the 6, I'm going to keep the 3. Since this is greater than 5 or greater, I'm going to round this up to a 4, and I'm going to record my answer as 0, 6, 4. That's 2 significant figures, and I have a placeholding 0 there that is not significant. Now let's look at number 14. Now we haven't talked about scientific notation yet, so you're probably going to, some of you, panic when you see that your calculator spits out this weird e-4 business, but all that's really trying to say is we're taking this number here and we're multiplying it by 10 to the negative 4th power, something we'll talk about in tomorrow's lesson. But for right now, what we have to keep in mind is this: significant figures. I have 4 significant figures here, I have 2 significant figures here, I'm limited to 2. I'm going to keep the 6, and I'm going to keep this 6, and that 9 tells me that this one has to be rounded up, so I'm going to record this as 6.7, and then for right now you can just write e-4, or if you prefer you could say times 10 to the negative 4th. Again, more on that tomorrow. And now let's look at number 15, perhaps the most frustrating one so far. So on number 15, what I see here is I have 3 significant figures here, but here I only have 1 significant figure. There's no decimal, therefore these trailing zeros are not significant. That means, my friends, I only get to keep one of these numbers, that one right there. And since that is, since this one is less than 5, what I end up having to write down is this: 1, 0, 0. I have to add the trailing zeros to keep the value of 1 in the hundreds place. So this number here, with all those digits, is going to be rounded into just that. So when we're recording values, we have to keep in mind that we are required to write down the ones that are significant and not ones that aren't. So when I look at this here, I see that this black rectangle here is definitely more than 20 and less than 30. So in my mind's eye, I just picture 10 tick marks between there, and I estimate what that gets to. I'd say that looks like it's about 20. I'm going to go with 23. You might have gone with 22. But nobody's going with 29. So in this case, I have 2 significant figures. The 20 I know for sure, and the 3 is a reasonable estimation that is likely to be reproducible by most people. Let's try 22. In this case, this rectangle has not quite gotten to here. Now, I can see that it's pretty close, so I still have a significant figure I can write down. I'm going to write down that I think it is 8. You might put down 9 or 7, but we'll probably all be plus or minus 1 of that, so therefore I have 1 significant figure here. Let's look at, let's not worry so much about 23. Let's look at 25. Well, let's look at 24. I just want to point out a mistake that I sometimes see. When you look at here, if you think that this is, let's just say you thought this was 2 3/4. Don't say, oh, it must be 2.75, because we don't really know the 7, therefore we can't know the 5. So I don't want you to write that down. If you thought this was 2.75, if you thought that was 2 3/4, you had to choose either 2.7 or 2.8. You don't get to have that extra digit there. Let's look at number 25. Now, look what it says. Be careful with these last 2. When this lands right on the money, here's what I want you to do. I want you to look at this, and I want you to say, okay, let's just say that this had landed 1 tick mark before here, in between this one and this one. Had that been the case, you would have called it 2.99. Now, that means you'd have 3 significant figures. Therefore, you have to write your answer to 3 significant figures here. So I would say 3.00. I know that's frustrating, but if you just write 3, that would lead me to think that you're using a ruler that's like this one here, that actually you think is more like this one here, and you're just guessing the 3. But in fact, you know with 3 digits of precision that it's right on the money. So let's try this one here. What we have here is it seems to land right on the 2. If it had landed here, I would have called it 1.9. That's 2 significant figures. I need to write my answer to 2 significant figures. I'm going to write it as 2.0.